Welcome to Study Loop.
So in this problem, we want to find the extreme values. So we're going to use the Lagrange multipliers. We're going to set the gradient of f equal to lambda times the gradient of g. So what this gives us is 1 equals lambda times 4x cubed minus 3x squared. And then it also gives us 0 equals 2 lambda y. We know that when g of xy is set equal to 0, that's the same thing as y squared plus x to the fourth minus x cubed equals 0. So we see that lambda cannot equal 0, because if lambda equals 0, then this would be 1 equals 0, which isn't true. So based on that, that tells us that y is equal to 0. And if we plug that into here, we end up getting that x is equal to 0, or x is equal to 1. So we know x equals 0 is impossible, because if that went in here, we would get 1 equals 0 again, so that can't be the case. So that concludes that x equals 1. So our only possible value is 1, 0, and that's the one we're going to focus on. We cannot tell, though, if this is a minimum or a maximum. So what we have is that based on our g function, y is equal to plus or minus the square root of x cubed minus x to the fourth. So it is defined only for 0 less than or equal to x, which is less than or equal to 1. So what we end up having is this right here. That's our graph, and we see that f of 0, 0 is actually going to give us the minimum. So since the gradient of f at xy equals 1, 0, what we end up getting is that 1, 0 is equal to lambda times 0, 0, and such a lambda does not exist. So we see that f of 0, 0 equal to 0 is the minimum, but the Lagrange condition is not satisfied. So we see that the Lagrange multipliers failed to find the minimum value in this case. And the reason why is because it requires that the gradient is not equal to g everywhere on the constraint curve, but as we saw, that was not the case. So that's why our Lagrange multipliers failed.